Okay. It does sound good, right? Okay. So, hi everyone. My name is Gregory Serna. I am a junior at UT, obviously. I am a CS major, and it died. Okay. Give me one sec. Okay. Okay. So, all right. So, and then I'm here to give you a talk today about 3D printing and how it turns the digital physical. I really love 3D printing. I've been doing it for about a year. I first got exposed to it. This is my printer that I built. It's actually the second one that I built. I built one in October, and then I shipped it out to California because I was working in California this summer, and it broke in the mail, so I just took all the usable parts and made a new one that was better, and it's much better. I can print better things now. But yeah, so I named it Hephaestus because Hephaestus is the Greek god of the forge, and this is kind of like having a mini factory in your own room. And so a RepRap Prusa i3, RepRap is an open source 3D printer movement, and the goal of the RepRap movement is to fully 3D print a 3D printer from a 3D printer, which is kind of weird to say, but and actually, so mine is mostly laser cut, but a lot of the printers, but like if you look right there in the bottom right, like that whole assembly is 3D printed, and a lot of the parts you can only 3D print now. So you usually just find someone who also has a 3D printer and ask them to print you the parts. You just kind of pay it forward. So, and it's dying again. I don't know why. It's usually fine.
It's the cord. It's fine.
Okay, so there are three main types of 3D printers, and 3D printers are actually a subset within a larger field of computer-aided manufacturing, or CAM, very similar to CAD, computer-aided design. Within CAM, you have 3D printers, you have CNC machines, you have laser cutters, you have the giant Japanese car robots, you have, but all of those things are subtractive manufacturing, is where you take a big block of something and then you cut away with it until you get the shape that you want. And that's kind of how manufacturing has traditionally been done throughout history. The cool thing about 3D printing is that it's additive. So you start from nothing, and then you build it up layer by layer, slowly, into a cool object. And so within 3D printers, there are three main kinds. So fused deposition modeling, which is kind of the classic model, and it's basically, it's very similar. You have a very precise hot glue gun strapped to a lot of motors, and then you just run it, and you have a computer attached to it. And that's kind of the classic version. The next kind is SLS, or selective laser sintering. That was actually invented by a professor here at UT in the 70s, Dr. Beeman, I believe. And the way that works is you have a really powerful laser melting some kind of powder material. And the powder can be metal, it can be ceramic, it can be plastic, it can be all kinds of stuff. So, and then basically you melt a pattern in a layer of powder, then you roll another layer of powder on top, and then you repeat the process, and then when you're done, you pull the part out of the powder. And so because it's within powder and it's fully like constrained, you can have even more interesting geometries of your objects than you can with FDM. And selective laser sintering is widely considered as the best form. It's the most precise. You can do the coolest stuff with it. It's also the most expensive and the most dangerous. But generally, SLS is like only like industrial-sized 3D printers. I only put a picture of an FDM printer because SLS and SLA printers are usually just really big boxes, so they're not very interesting because they just do everything inside. But they're really, really huge, like as tall as that and like 10 feet wide and like 5 feet thick. The Objet just came out with a printer that has a cubic meter build area, which is massive. And then so stereolithography is the final version, and it's SLA, and basically that's kind of like SLS, but instead of powder you have liquid resin, and then you use a UV laser to cure the resin layer by layer by layer. And it works similarly, but it's more precise than FDM, but it's kind of annoying because it's liquid and it's messy, and like when changing colors you have to like wash it out, and it's kind of a pain. It's also generally more industrial. So within FDM printers, which is the kind I have and I know the most about, here kind of most printers are either Cartesian or Delta. Cartesian is XYZ, right? And most printers are that way because it's just the simplest to program. MakerBot is right there, and that's the Object 1000. It's the giant meter one. As you can see, it's just really freaking big. And then right there is the Delta printer, which looks like it's from the future, and that's why I love it. It's because you have 3 rods, and then the head just kind of suspends and it just does it. It looks really cool when you watch it running. It looks crazy. That's the next one I'm going to build. And so FDM printers use spools of filament. You might have seen in the previous picture. It's just giant rolls of plastic thread, and then it pulls it in, and then it melts it, and then it like extrudes it out very precisely. And then so you get different properties of your objects based on what kind of plastics you use. The most popular kinds of plastic are ABS and PLA, which ABS is more temperature resistant, and you can do more like post-processing with it. It's the same kind of plastic that Legos are made out of, so it's very strong. PLA is a bioplastic. It's recyclable. It's a little less strong, but it's much easier to work with. It doesn't warp when you print, which is so nice. ABS, it's a huge pain because you have to do it like 3 times before you get it right. And the nylon is very high temperature resistant. There are flexible plastics. There are wood-based plastics. It smells like wood when you print them. It looks like wood. There are glow-in-the-dark plastics, there are translucent plastics, there are color-changing plastics, there are water-soluble plastics that use as support. There's tons of different kinds. Okay, so I'm going to show you what I usually do to make a new object. So the Longhorns that I've been giving you, it's actually a design that I created and uploaded to Thingiverse. Thingiverse is where I get most of my models. It's owned and run by MakerBot, and everything on there is free. It's really awesome. And then people just share and comment and give advice and remix and stuff like that, and some really interesting things have come out of it. It's kind of like the social network for 3D printing. And so I download this, right, as a .stl file. Next, I load the file up in Slicer, which is kind of what slicing is when you take the model, which is just a mesh of the object, and then you turn it into like discrete layers and machine code. So you take the STL and turn it into G code. And then so this is where like a lot of the art of 3D printing comes in, because the real difficult part is not building it, but just getting it to work the way you want it to, because it messes up a lot. And so there's all kinds of different settings and things you can tweak and things to speed it up or slow it down and make it like nicer or higher quality. And then so you put it through this, and then you press go, and then it exports G code, and then from there you load it into Pronterface, which is the host program for 3D printing. And there are lots of different host programs. Some hosts combine slicing and like delivering the code to the machine in one. MakerBot does that. MakerBot is kind of like the Apple of 3D printing. It's very easy to use, but very expensive. And then so that's kind of an example of like the different paths throughout the model. It's kind of halfway through. One cool thing about 3D printing you might be able to see, that for those of you who have Longhorns already, is that you use infill, which is kind of like a hexagon shape, in order to waste less plastic and make it run faster. Okay, next slide. All right, and then so you print. So I only showed one print, but I was printing about 8 of these at a time. I printed about 20. And you just kind of go. And then like I went to class. I set it up before I went to class, and then came back, and I had Longhorns. Yay. And it's awesome. I used to not be able to do that. I used to have to watch it, which is a really big pain and a really big time suck. But yeah, and then so it just runs, and then after you're done, you have a handful of Longhorns. And that's how you print stuff. So now that you guys know how the basics of 3D printing work, I'm going to talk a lot about why I think it's really important and really cool. So 3D printing is never ever meant to replace traditional manufacturing, like which is kind of injection molded, where you can make 1,000 at a time, and it's just really fast. And really cheap. Like injection molding is really cheap because as long as you have the mold, which is the most expensive part, you can make as many as you want. So 3D printing is never going to do that. Like strawberry containers are injection molded. I'm never going to 3D print strawberry containers. It's dumb. It just would not. It's not time or money like efficient. So what 3D printing, its main benefits is that it brings the digital properties of digital objects like media and music and movies and all that kind of stuff into the physical world. So because everything with 3D printing starts out as digital and you just bring it into the physical world, all those properties are still retained. So the properties that make the internet what it is that you can reproduce anything as many times as you want with zero cost. You can change things as much as you want, and you can customize it any way you want. Like, there are hundreds of millions of websites out there because people customize them the way they want to and do a very specific thing with them. And then people rapidly iterate. You throw it up and, okay, it's kind of crappy right now, but in 2 days I'll make it better, and you just kind of improve it. Like Facebook 10 years ago was really awful compared to what it is now, but they just worked on it and worked on it and worked on it. And so those properties now exist for physical objects. Before, you didn't have that. You kind of built your design, you shipped it off to the manufacturer in China, and you came back and, okay, is this good or not? No, it's crappy, let's change this, this, and this, and then ship it off again. And the times just take forever. But with this, you have it on your desk, and then you can just do things really quickly. Okay, next slide. So I'm going to talk about each one of these. So, infinite replication, which is kind of a really big issue with like media and stuff like that. Like big copyright companies hate that you can copy a song as many times as you want with no cost. But it's kind of inherent in the way that digital technologies work. So as some of you might have seen, there are a lot of little LANs in the labs over the past couple of weeks to kind of raise awareness about LAN, whether you're rushing. That was me. I printed all those. I printed about 150 of them in about a week, and it costs about $10. Another really awesome thing that's very similar to the internet is things are really cheap. A roll of filament costs about $30, but it'll last you about 2 months, and you can print a ton of stuff with that. Like, I've only used up like 2 or 3 rolls total in the year I've been printing. And as soon as you digitize an object, you can make as many copies as you want. If you scan something, you can replicate it as many times as you want, which leads to a lot of problems, because if you it's kind of the whole copyright thing of like music. Once you have a copy of music and you share it as many times as you want, there's nothing really stopping you, because that's just the way technology works. But like, should we do that? And like, I mean, you wouldn't download a car, but if someone scanned all the parts of a car, you can print them yourself. Like, there's nothing really stopping you from doing that. And then piracy with like guns and like 3D printed guns is a question that I get asked a lot, and I've never made one, and I don't really plan to, but it is a difficult subject to talk about, because like on one hand you're like, privacy's fine, or piracy's bad, but like on the other hand you want to enable free sharing, all that stuff. So it's a difficult argument. So next question. All right, so rapid iteration. So right here, so as some of you might know, probably most of you don't, I live in a co-op of about 20 people, and one of the reasons why I wanted to live there is because I would have a lot of ideas, a lot of people to give me ideas of how I can fix things in the co-op, because co-op's a little bit run down and unusual. I mean, it's just kind of how it works. For example, so on the far right, we had a broken blender. The bottom was broken off, and then we couldn't blend anything because you put it on the blender mount, like whatever it's called, and it would just fall off. And you'd either have to hold it while you blended things, or you just didn't blend anything. And so what I did is I printed a base. It was just literally like a rectangle around it, and it just fixed it. And it was really, really easy, but there's not really any other easy way to do that, like unless you like nailed some boards together, which would be a huge pain, and if you mess up, then you have to redo everything, you have to get new boards, and it's just it's difficult to do otherwise. But with this, I made like 4 different versions, and I just tried to get the right size right to where it was a tight fit, and then I just went. Like, it's not glued on or anything, it's just there. The next version is all the sinks in our house didn't have drain covers, and so people would like lose things occasionally, and I almost lost my ring, so I was like, I don't want to do this, so I printed a drain cover. I mean, the drain cover that I found online for free wasn't the right size, so I printed about 3 different versions to get the right size, and then it fits perfectly now, and I printed one for almost everyone in the house, and everyone loves it. And the third one is a robot that I printed during a hackathon over the summer. It was a 3-day hackathon, and we found this model online, and then it was really cool, but there were some things about it that we didn't want to do. Like, it was 6 legs instead of 4, we didn't have like enough, the Arduino couldn't push enough motors for 6 legs, and it was bad. But it was really fun, but we just kind of had to literally hack it together. So I customized the model of the robot, and the whole robot is 3D printed, along with like wires and stuff like that. And so you can rapidly iterate on things, and then I mean, since it's so cheap, you can just throw it away once you're done. It doesn't take that long, and you can just come up with the final design, and then once you have the final design, you can make as many as you want, which goes back to the previous slide. All right, next slide. So customization. So what does SpaceX have to do with French House? So SpaceX's new rocket, or new capsule, which is the first ever private spaceship to support human astronauts. It can support like 7 people. Some of the engines on it are 3D printed, which in my mind just blows my mind because my printer is like not that great. It's pretty cheap, but like the fact that you could scale up 3D printing and make it so precise and so strong that you could print a rocket engine, it blows my mind. But it kind of gives evidence that this isn't just kind of like for toys. This is for real things. And I'm sure, and then the turnover process for designing a new version of the rocket engine and then making it and then is much faster than like sending it off to some giant company somewhere that like builds it. I don't even know how rocket engines are made. Like, it's a mystery to me. Rocket scientists are rocket scientists for a reason. And so like the next customization thing is Robert loves web dev, as you guys have just heard. His birthday was a couple of weeks ago, and I printed him a little name tag that said Web Dev Wizard on it, which was a nickname I gave him over the summer. And I just made it in about an hour. I went from idea to finished object in about 3 hours, which is pretty cool. And then French House is the name of my co-op, and I printed those as magnets for a fridge. And there's a quick, easy thing to make, and people really like them. But so what people really love about 3D printing is that, and so what I print most than anything else is gifts for people, because I just like giving things away. And it's not very expensive. They're really great birthday gifts. Is that you give something very unique to them that no one else has. And with the way things are today, with everything being so replicable and very mass manufactured, people love the uniqueness. People have literally asked me, can you print me something that you haven't printed for anyone else? People want that. People love the unique factor and the customizability of everything, which I think is a really interesting insight into our society today. Okay, so that kind of wraps up like the main 3 tenets of why 3D printing is so strong. So we have some cool 3D printing resources on campus. Maker Studio is a brand new engineering school initiative to where they have a makerspace in ETC. It's open most of the day. I think you have to be an engineer, but I would either find an engineer or just say you're one. I don't really think it's strictly enforced. And then so Innovation Station, which is open to the entire campus, and it's a 3D printing vending machine. It's actually just got launched this semester. It's actually really, really cool, and it's totally free because they can't charge for like messed up parts. But so you queue up your print online, and then you come later in the week, and it'll send you an email when it's done, and then it'll just be in the bin. And then it's a free 3D printing vending machine, and it's all about like lowering the cost to 3D printing. And they have a really cool mechanism to where they can just like scoop off the prints when they're done, which I really wish I could have, because it's kind of annoying to come back and have to like re-queue things. And then so the next website is Make XYZ, which is kind of like 3D printer classifieds, if that makes sense. People who have 3D printers in the area list their printer, and other people who need rapid designs or like prototypes of things that they're making and stuff like that can ask you, and you pay them and say, but it's much cheaper than like online websites like Shapeways. Shapeways has a lot of really awesome options, like you can get things like printed in gold. It's really expensive, but it's really cool. But Make XYZ is cheaper, it's faster, and it's local. It's really great, and it's a local Austin startup as well. So I definitely recommend checking that out. And I've had I'm on there as well, and I've had people like come ask me some really crazy things. This one guy asked me to print a hand for he was a teacher, and he asked me to print a hand for one of his students who was missing a hand. And that just blew my mind, because that you can do that if you have a nice enough printer. I didn't, so I was like, I can't do this. I don't want to create a crappy hand for you. But I want it to be nice. But so I pointed them to some other people who have better printers, and I pointed them to the mechanical engineering department, because they're doing cool stuff with 3D printed prosthetics. But yeah, Make XYZ is awesome, and some really interesting really interesting things have been on there. Thingiverse.com, I talked about it earlier. It's kind of a giant repo of 3D models. Everything on there is free, and it's pretty great. And there's just a crazy variety of things that you can find on there. And the reprap.org, which is the RepRap's website. RepRap has like the cheapest 3D printers. They're a little harder to maintain and use, but it's definitely, if you like tinkering, you like building stuff, I would definitely recommend getting RepRap. It's been a lot of fun. It's a lot of blood, sweat, and tears, but I'm really, really glad that I built a printer. It's been a really awesome year since then. And yeah, so, and that's it. Any questions? And like in the previous talk, if you ask a question, I will give you a 3D printed Longhorn. Yes?
I'm curious about the price of the typical machines. And you said they're kind of all over the place.
Yeah, so with 3D printers, and basically with everything in 3D printing, it's very price, you get what you pay for. Like, it's very strongly correlated. You can buy a $300 printer on Kickstarter. It's kind of like the entry price point that a lot of Kickstarters are going for. But I wouldn't recommend it because they will usually not be good, or they will take like 6 months longer than they promised to ship it to you. My printer was about $800, although I've sunk a lot more money into it since then, and repairing and upgrading and things like that. But and then the MakerBots on the high end are about $2,700 for like the replicator, the one that I have a picture of, and they have like a mini, which is pretty cool. It's about $1,500. And then there's a lot of different options. It's kind of hard to find because there's so many, and it's very there's not really like a central place for like information about it. It's just very internet based, so you read a lot of blogs. But yeah, I would just do research on it and then find it. I would probably go for around $1,000 to $1,500 is like the best sweet spot for like quality and price, I would say. Yeah?
What materials can you do out of yours?
So I can do ABS, PLA, and the laywood, which is like the wood version. The wood version actually pretty cool. I printed some interesting things with it. I printed a tree, which was my first idea. But it's kind of annoying too because, so it's 40% wood particulate and 60% plastic. And it smells like wood when it prints. And you can vary the temperature to like vary how dark it prints out. It's pretty cool. And you create like rings and stuff. But the issue is like the filament literally burns in the extruder if you leave it in there too long. So it's kind of finicky to use. I can also print with nylon, but I don't have any because it's expensive. But yeah, PLA is by far my favorite. It's just doesn't warp, and it's easy to use, and it's cheap. So, yeah. Yeah.
So, have you experimented with any of the stereolithography outcomes, like the Form 1 or like?
So those are hard to get your hands on. They're expensive, and I don't really have money for it. I mean, I've been meaning to go see if I can like talk to someone and play around with mechanical engineering stuff, because they have like a giant advanced manufacturing lab. I haven't been in there, but it sounds really cool, and I know that they do lots of 3D printing stuff in there. And they have SLS machines, which is SLA. I don't know. SLA is good for certain things, but not really. It's like very specific use cases. I don't know how to explain it, but SLA is generally like the most rare of the three kinds. Yeah.
When you said that you printed your tree, does that mean that, let's say you wanted to do green leaves and a brown trunk, do you have to do 2 runs, output G-code, do 2 different prints?
So the tree I printed had no leaves. It was a dead tree. But so there are printers with multiple extruders. Generally, like 2 is the most common. If you have multiple, anything past 3 is. I mean, with each increasing extruder, you have an additional complexity in like switching off and making sure things don't interfere. I've seen a printer with 6, which was just crazy. I don't know how it like ever got it to work. Yeah. So with multiple extruders, you kind of just like switch off mid-print. You can't really do multiple rounds just because since it's layer based. But even then with like with 2 extruders, usually one is the regular filament and the other one is a water-soluble type of filament that you use as support for your print. And you basically, after it's done, you just dunk it in water and then all the support comes off, which is actually really nice. And that's actually a big drawback to 3D printing, is that most things are single material. Most things that you can print are single material. And most things that we have and own around us are not single material. Most things are like mixes of things and like all kinds of different materials added together, and it's just kind of it's hard to scale up to more complex things unless you do a lot of like work and printing separate pieces and adding them together.
Well, I think we're out of time, so
Okay.
thank you guys for coming.
All right. Well, if anyone else wants prints, I have a lot of them, and I don't really want them, so you're free to take one. But yeah, it was very good talking to you all.